everyone. So I wanted to talk a little bit in this video about equations of lines and parallel and perpendicular lines and what we do with those in college algebra. So equations of lines, you may remember from other math classes. A lot of people often remember y equals mx plus b. Okay, I'm just writing it here. I know it's kind of small at the moment, but you can see on your paper right here, y equals mx plus b. That's what we call the slope-intercept form of a line. It's just a certain way that we can write the equation of a line. And the way that's written, the format of it, is y equals, so we're solving for y, mx plus b. M and b are going to be numbers. M is going to be the slope of the line, and b is going to be the y-intercept, or the point where the line crosses the y-axis. So we talked about slope already. We talked about which axis is the y-axis, so this would be where the point crosses that. So in order to make your line equation in the slope-intercept form, you need to solve for y. So if you're given the equation of your line in another format, like here's 3x plus 4y equals 12, in order to figure out the slope and the y-intercept, we want to put it into this form, in other words, solving for y. So again, this is something that was in that review at the end of graphing, and this is why, because we're using it here. So we would want to get y by itself, so we can subtract 3x, divide everything by 4. Y is going to equal negative 3/4 x plus 3. We reduce this to get 3. Now I can find, because it's in the slope-intercept form, whatever number is in front of the x is going to be our slope, and whatever the other number is going to be our y-intercept, or where that line would cross the y-axis. Okay, so let's go ahead and look at an example. This is just to get it into slope-intercept form. Let's look at an example of what we can do once we have it. So this equation right here, if I'm trying to graph this line, this equation right here is already in slope-intercept form. It's y equals a number times x plus another number. This number is my slope, not the x, just the number. This number is my y-intercept. So I just wrote those over here to remind myself. So slope is negative 3/4, and the y-intercept is 2. And then I wrote a little bit more information about each one of those. Remember, slope tells us how we get from one point to another point on that graph. Okay, and then the y-intercept is, again, where that line crosses the y-axis. Remember, this is the y-axis. So it's a point 0, 2, right? 2 on the y-axis is the same as the ordered pair 0, 2. We talked about pairs again in the review. So my slope, if I have negative 3 over positive 4, remember slope is rise over run. Rise means I'm going to go up or down. Because this is negative, I would go down. Run means I'm going left or right. Because this 4 by itself is positive, I'm going to move right. So I can graph this point by starting out at the y-intercept, starting out with this point on the y-axis. I would have just that single point there to begin with, and then I can use the slope to move to the next point. I can go down 3 and right 4, sorry. Down 3 more, right 4, and I have made these points. Then I can connect them with using my ruler. You want to connect them in such a way that it fills up the whole graph, not just a couple little points worth here. And then we always label it with our equation of our line. We talked a little bit in the review packet about slopes. And if you remember, we said negative slopes, they're slanted in such a way that you can make an N. So that's kind of our trick. So if I check this, I can see that it does indeed make an N. Here's another example. This one is not in slope-intercept form. So in order to graph it, I need to put it in slope-intercept form. You can see these steps here. You can pause the video if you want to take a minute to look those over. Here I have it in slope-intercept form. This number is my slope. This number is my y-intercept. Notice that as I'm solving it, I put the x term first. So when I subtracted this, I ended up with negative 3x plus 2. Put the x term first because that's how I want it in that format. Slope. Both parts, the rise and run, are positive, so we're going to go up and to the right. My y-intercept this time is -1, so I start here 1 below the x-axis. Then I go up 3 over 2, up 3 over 2, and then draw that line. Okay, let's see here. So we have a few more examples. These two are both examples where one way to deal with it is to use that LCD method that we reviewed in the review part. So if you notice here, my LCD is 12. So I multiplied everything by 12. Then I got an equation that had no fractions, and then I proceeded from there. So again, you can pause the video or just on your own look at the notes, and you can see how that worked. Once I have it in in slope-intercept form, y equals mx plus b, I start with my y-intercept, then I use my slope to move to the next point. All right, let's see here. Another way we can graph a linear equation is we can find the x and the y-intercepts. So this only works in some situations. Really, it's probably a better idea to generally use slope-intercept form, but just to show you, this is a situation where we can do this. And we notice that 5 and 3 here are both factors of 15. That means if I'm trying to get one of them by itself and I divide by that number, this will come out to a whole number, which is nice. So if I think about this, if I want to find my y-intercept first, anything along the y-axis, my x is going to be 0. Okay, so let's think about that again for a minute. Any point on the y-axis, I go up or down, but I didn't go left or right at all first. My x value is going to be 0. So if I plug 0 in for x, this goes away, because 5 times 0 is 0. I have negative 3y equals 15. I divide y equals negative 5. That's my y-intercept. Same idea for x. Anything that's on the x-axis goes left or right a certain amount, and then it doesn't go up and down, or else it would go off the x-axis. So I make y equal to 0. Again, this goes away because it's 0. So I get 5x equals 15, x equals 3. My x-intercept is 3, 0. Now you can do this with any equation, but often your intercept will come out to be a fraction. So that's why we don't often do this. But again, if you see that both of these numbers are factors of this number, then they will always come out even. All right, horizontal and vertical lines, they're a little bit different than other linear equations. A vertical line is just x equals a number, okay? Because my y, it doesn't matter what my y is in this case, x is always going to be negative 4, okay? Here, it doesn't matter what my x is, my y is always going to be positive 5. If you are ever working with horizontal and vertical lines and you're not sure about which is x and which is y, which is x equals and which is y equals, you can always make yourself a little table, right? If I'm given this equation or this line and I want to figure out what it is, you could say, oh, well, one point is negative 4, 2, negative 4, 6, negative 4, negative 5. All the x's are negative 4. Or if you're asked to graph x equals negative 4, you can make a little table knowing that the x is always going to be negative 4 and the y, could be anything. All right, the next part about point slope form, I'm kind of going to let you read that on your own. But again, if you have any questions on it, jump onto Zoom or email me for sure. So this is, let's see, so let's go past these. Okay, so let's go here to example 20, okay? And I'm asked for a couple of these here to find the equation of a line that passes through certain points, negative 3, negative 5, and 2, 5. So let me switch over to the whiteboard so we can take a look at this. So it's negative 3, negative 5, and 2, 5. Those are our points. Let me get a better pen here. Okay, so basically what's happening here is we don't have a graph, a picture to look at. But what it's saying is there's a line that goes through the points negative 3, negative 5. So just as a very rough sketch, negative 3, negative 5, here's one point. and through the point 2, positive 5. So then we have a line that goes through those 2 points. Okay, so here's my line. Now, once I have 2 points, there's only one line that can go through there. If I had just 1 point and I said, here's 1 point, well, there are an infinite number of lines that could be drawn through that 1 point. But once I have another point, now there's only one line that goes through those 2. So if we have 2 points, there's only one linear equation, one straight line that can go through those 2 points. So I'm being asked to find the equation that the equation, the y equals mx plus b, that describes this line. Okay, well, we know in an equation we need a number for m and a number for b, a number for the slope and a number for the y-intercept. How do we find slope? Well, thinking back, we find slope using our formula, y2 minus y1 over x2 minus x1. So it doesn't matter which way I go as long as I'm consistent. If I do -5 minus 5, if I do top minus bottom, then here I do -5 minus 5, top minus bottom. I would get -10 over -5, which is positive 2. So my slope is positive 2. Now I need to find b. Well, in general, if I'm trying to solve an equation for a certain variable, I can do that if that variable is the only thing I don't know. If I have one unknown, then I can solve. So I want to solve for b. That means if I could substitute something in for x and y, I would be able to solve for b. Well, looking up here, I have 2 possibilities for x and y. I can take either of these original points I was given, plug it in for x and y. Okay? You have to obviously use the same x and y from the same point. So you could either use -3, -5, or you could use 2, 5. I'm going to choose to use 2, 5, just because it's always a little easier to deal with positives, but either one will give you the same answer. So 5 equals 4 plus b, subtract 4 from both sides, 1 equals b. Again, if I had plugged these 2 in, I would have gotten the same thing. So now I have y equals mx, well I know that's 2x plus 1. Okay? This is my equation for the line that goes through these 2 points. Now normally we just sketch this, right? You're not given the graph often. This is just kind of something we did just to get a sense of what was happening. You can do that though, and now you see it should be a positive slope. Mine doesn't exactly go through 1, but it was a very rough sketch, but it's very close to 1. So it does make sense that that is the equation. Now on that page, I also did it another way using that point slope form, which is just another version of a way to write a line. But I'll let you look through that on your own. Okay, so anytime we have, so 19, 20, 21 all asks for the same idea, for finding that equation. When you're finding the equation of a line and you're giving it in slope-intercept form, then you always want to think of that y equals mx plus b. Number 22 is like a word problem. I'll let you look at that. Again, if you have questions, let me know. And then that brings us to parallel and perpendicular lines. So I only have a very short amount of time on this video until I'm out of time. So I'm going to stop it, and then I'm going to go on and I will do parallel and perpendicular lines in a new one, so we're not so rushed, all right?